Good afternoon, everyone. Am I audible?
Yes.
Yes. I'm Dr. S.N Jyothi, Associate Dean of School of Engineering, Amrita Vishwavidyapetham University, Kerala, India. I consider it to be an honor to be invited to give a presentation on our paper titled Assessment of Water Quality Index and Study of the Impact of Pollution on the Rivers of Kerala at the International Conference on Food Technology and Nutrition. The state of Kerala is located along the southwestern coast of the Indian subcontinent, and Kerala lies between the Arabian Sea to its west and the Western Ghats mountain range on its east. The climate of Kerala is predominantly wet and tropical. The monsoon winds heavily influence the seasonal precipitation in the state. Kerala is blessed with 44 rivers, out of which 41 of them originate from Western Ghats and flow westward. The remaining three rivers flow eastward. The state is also nourished by a chain of freshwater and estuarine lakes and backwaters. Lush green forests, pristine rivulets, and stunning seashores are nature's gift to the state. Water, the elixir of life, is a crucial element for all the biological reactions and sustains life on planet Earth. Anthropogenic activities have resulted in the introduction of various substances into water bodies. When the concentration of such substances exceeds the tolerable limits, the water bodies get polluted and become unfit for domestic consumption. Evaluation of the degree of pollution in the water bodies is becoming a matter of prime concern globally as the number of countries becoming water stressed is on the rise. In India, the per capita water availability is reducing due to the rise in population and reduction in the availability of clean water due to pollution. Rising level of pollutants in the water bodies of India as a matter that has still not received the deserved attention. Most of the population in India depends on rivers for their domestic water consumption. Quality of water depends on sorry Quality of water depends on various physicochemical parameters, and the tolerable limits for these parameters are set by various organizations like the World Health Organization, Indian Council for Medical Research, and Bureau of Indian Standards. It's difficult for a common man to understand the significance of each of these parameters like pH, conductivity, dissolved oxygen, dissolved solids, etc., and the role it plays in estimating the quality of water. It is therefore necessary to report a single number called Water Quality Index WQI that encompasses the impact of all the parameters to convey the quality of water. Water Quality Index can be used to rank the water bodies into various categories like excellent, good, poor, unsuitable for drinking, etc. Kerala is the southernmost state in the Indian peninsula. It is situated between 8 degree north to 12 degree north and 74 degree east to 77 degree east. Out of the 44 rivers in Kerala, we have chosen 10 rivers and evaluated the water quality index for these rivers using both the Indian method and the Canadian method. These 10 rivers were divided into three zones based on their geographical locations as Southern Zone, Central Zone, and Northern Zone and analyzed closely. The rivers Chandragiri, Chalia, Kadalundi, and Haridapura were grouped under the North Zone. The rivers Chalakudi, Muvatupura, and Periya were grouped under the Central Zone, while the rivers Pamba, Kallada, and Achankovil were placed under the South Zone. There are several ways to compute the water quality index. A quality rating method to calculate WQI, referred to as Indian method, and a method evolved by the British Columbia Ministry of Environment, Lands and Parks, and later modified by Alberta Environment to calculate WQI, referred to as Canadian method. All the data regarding the various parameters pertaining to the quality like pH, chlorides, electrical conductivity, magnesium, total dissolved solids, nitrates, total alkalinity, total dissolved oxygen, total hardness, BOD, calcium, total coliform, and fecal coliform were obtained from the Kerala State Pollution Control Board Water and Air Quality Directory. The WQI was evaluated with the allowable limits for drinking water set by ICMR and BIS standards. A generic and reliable sea language code that quickly computes the water quality index for different water bodies after accepting the various parameters as input was developed. The water quality index is then calculated using this code. The C language computer program was able to exactly match the calculation for the Canadian method mentioned in the CCME Water Quality Index 1.0 Users Manual, and as well as for the Indian method mentioned in the paper authored by Sri Bala et al. The water quality index is estimated for the Indian method using 11 parameters that are listed here. The 11 parameters: pH, electrical conductivity, total dissolved solids, total hardness, calcium, magnesium, total alkalinity, chlorides, nitrates, dissolved oxygen, and BOD. The method computes WQI using quality rating, unit weight, and standard limits, which we will see shortly. According to the Indian model, the water quality is categorized into the following: excellent water quality 0 to 25, good water quality 26 to 50, poor quality 51 to 75, very poor quality 76 to 100, greater than 100, unfit for consumption. The quality rating QN is 100 multiplied by Vn minus VIO divided by Sn minus VIO, where Qn is the quality rating for the nth water quality parameter. Sn, the standard permissible value of nth parameter. VIO, ideal value of nth parameter in clean water. Vn, the measured value. Wn, unit weight. And water quality index is sigma Qn Wn divided by sigma Wn. The parameters entered as input for the river Achankovil are pH 7.3, conductivity 144 micromoles per centimeter, total dissolved solids 93 milligrams per liter, total alkalinity 25 milligrams per liter, hardness 46 milligrams per liter, calcium 20 milligrams per liter, magnesium 26 milligrams per liter, chlorides 30 milligrams per liter, nitrates 0.52 milligrams per liter, dissolved oxygen 5.5 milligrams per liter, BOD 1.4 milligrams per liter, and the computer program displays the calculated WQI as 49.8. In order to calculate the WQI using the Canadian method, a minimum of 4 parameters measured at least 4 times is required. But there is no maximum limit on the parameters that can be used to determine the WQI. In this study, we have used 5 parameters: pH, dissolved oxygen, BOD, total coliform, and fecal coliform measured for 6 years, that is from 2012 to 2017, to compute the WQI for 10 rivers in Kerala. According to the Canadian model, the water quality is characterized into the following: excellent 95 to 100, good 80 to 94, fair 65 to 79, marginal 45 to 64, and poor 0 to 44. In this study, a computer programming in C language had been developed to compute the CCME WQI. The program accepts the concentration of parameters pH, dissolved oxygen, BOD, total coliform, and fecal coliform for 6 years as input and displays the CCME as output. Three factors F1, F2, F3 are needed to compute the WQI. Step 1 is to calculate F1, the scope, which is total number of failed parameters divided by total number of parameters multiplied by 100. Step 2 is to calculate frequency, which is total number of failed tests divided by total number of tests multiplied by 100. Third step is to determine the amplitude F3, which is normalized sum of excursions divided by 0.01 into normalized sum of excursions plus 1. These normalized sum of excursions actually indicate the deviation of the sample from standards. Finally, the CCME WQI is equal to 100 minus square root of F1 square plus F2 square plus F3 square divided by 1.732. The Achankovil River and Kallada River in the South Zone have good water quality as per both Indian method and Canadian method. The Pamba River has a good water quality at the Chennannur and Tagari river station, but it only has marginal water quality at Parumala river station as per the Canadian method. On careful analysis, the WQI of the Pamba River is of good water quality according to the Indian method. The figure illustrates the CCME WQI of the rivers in the South Zone over the 6-year time period and the WQI of the rivers in the South Zone as per the Indian method for the year 2017. Even though the water quality of Pamba River is categorized as good under the Indian method, since the WQI value is closer to the upper limit, it is ideal to classify the water of Pamba River at river station Parumala as of marginal quality. Regarding the central zone rivers, most of the river stations of Periyar River has been classified as fair and marginal as per the CCME WQI. The figures show CCME WQI of the rivers in the central zone over the 6-year time period and the WQI of the rivers in the south zone as per the Indian method. The river stations Elur and Padalam have water quality unsuitable for consumption as per the Indian method for the year 2017. The data indicates that water in this section of the river is polluted. The data also show that the levels of total coliform and fecal coliform concentrations are quite high at these river stations. One of the main sources for coliform bacteria is unprocessed waste from septic tanks. It can be observed that the banks of the river Periyar are thickly populated with many high-rise apartments, hotels, and resorts situated along the river banks. It is probable that if sewage is released into the river without appropriate treatment, the coliform content in water will increase. This, however, is only a hypothesis which can be truly verified upon carefully and in-depth study of more samples of water taken from multiple points along the river. About the northern zone rivers, Bharatapuzha and Kadalundi, they are placed in the good water quality according to the CCME WQI. The figures show the CCME WQI of the rivers in the north zone over the 6-year time period and the WQI of the rivers in the north zone as per the Indian method. The Chalia River is, however, classified as fair according to the CCME WQI. The river Chandragiri has a good water quality as per the CCME WQI, but the WQI could not be calculated for Indian method for the year 2017 since the river was dry. The river Chalia has a very poor water quality at the river station Chungapalli. The data for the year 2017 shows that the concentration of the parameters like hardness, chlorides, calcium sulfates, total suspended solids, and dissolved solids are at order of magnitude above the permissible limits. A more detailed study will be required to identify the source of pollution as point sources could not be identified on the first round of investigation. Now, few conclusions that we have found out are total of 13 parameters are used to generate the water quality index for the Canadian method and Indian method. The CCMA WQI is calculated using the data for the years 2012 to 2017. So it gives us an idea about the average quality of the river over the past 6 years. The WQI calculated using the Indian method is only for the year 2017, which shows the most recent status of the river. The WQI calculated using the Indian method may be more accurate as it uses 11 parameters to compute the index. However, it will give only a single value for the data input. If the WQI for the past years is needed, then the index has to be computed separately for each year. The CCME WQI, on the other hand, gives an index value for the data input for all the years. In our study, the CCME WQI was computed only for 5 parameters, and the accuracy can be improved if more parameters are used to compute the CCME WQI, which was done as part of our later studies. Most of the rivers evaluated in the southern zone generally have good quality water. Most of the rivers in the north, except the river Chalia, have good water quality over the past 6 years. However, the status of most of the rivers are poor for the year 2017. The quality of water in most of the rivers in central zone is classified as fair and marginal according to CCME WQI. The data indicates that the rivers are polluted due to industrial and urban activities. A detailed survey of these river stations has to be conducted in order to identify the source of pollution. Mitigation measures to reduce the impact of pollution on water quality can be recommended only when the source of pollution is clearly identified. Some of the references we have used in this paper. Thank you so much for the patient hearing. Thank you.